Good afternoon, ladies and gentlemen, and welcome to the SAIEE Computing Chapter webinar on cloud computing, how to improve your productivity. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the Computing Chapter playlist. You will find the link to the registration in the chat function. Please register, it's free. A certificate of attendance will be issued a few days after this webinar. I'd like to introduce you now to our host for tonight, Mr. Sean Poppy, who is from the SAIEE Computing Chapter, and he is a senior researcher at the Eskom Research Testing and Development Business Unit with over 10 years of experience in researching and standardizing systems, architecture and communication protocols in smart metering and electric mobility. He represents Eskom and IEC TC13 and W14, Smart Metering Data Exchange, and IEC TC69, Electrically Propelled Vehicles and Trucks. Over to you, Sean.
Thanks, Minx. Thank you very much. I'd like to welcome everyone to the SAIEE Cloud Computing webinar this evening. It's going to be an exciting hour or so, and hopefully all of us will learn a lot. The computing chapter within SAIEE is a subsection of the electronics and software section. Essentially, the aim of this chapter is to provide information timelessly on topics that cover the computing industry as a whole, provide in-depth training and also provide knowledge-driven advice through meetings and webinars of this nature. And it's open to all professionals within the computing industry. So would really welcome anyone who would like to participate and contribute. Also want to extend a welcome to our wonderful presenters who are very knowledgeable in cloud computing, and in the next few minutes they'll be sharing their knowledge with us. So a warm welcome to them. And at this point, I think Minx, you can please put up the first presenter. And as the presenters are presenting, I encourage all attendees to start posting questions on the chat, and those will then be addressed later on in the Q&A session of the webinar. Minx, are you with us?
Yes, I am. You can read Terence's bio on the screen.
All right. It's not changing. It's not showing at this point. Yeah.
Okay, I will do that. It's changed on my side. It might be just a lag on your side. Our first presenter for tonight is Mr. Terence Naidu, who's a solutions architecture leader from Amazon Web Services. Terence leads the solutions architecture function for Amazon Web Services, AWS, in South Africa. With over 18 years of experience in technology consulting, IT strategy and architecture, Terence has spent most of his career in financial services, driving strategic transformation through technology. In his current role, Terence leads a team of experts who work closely with AWS customers to drive the adoption of best practice architectures in the cloud and enable customer teams on AWS services and approaches. Terence is a recognized thought leader in technology and brings knowledge and experience to the AWS South Africa consumer base. Over to you, Terence.
Thank you very much, Minx and Sean, for that introduction, and thank you for inviting me here today. I'm just going to share my screen and then we can get started. Just want to see. Okay, can you see my screen?
Yes, we can.
Okay, perfect. So I know we're talking about productivity today, but related to productivity, there are two types I see: productivity in you as an engineer or as an individual, in how you go about doing your work and how you get to your results faster, but also in the value of the work not done by leveraging innovation around you, and how you can use something like cloud computing to get to your end business result or goal, or the goal of your organization quicker. So we're going to look at a bit about how you increase your pace of innovation. But before we get into that, I just want to set the scene. We have lots and lots of challenges today as businesses and organizations in South Africa. Some of those are international. We see the same companies overseas facing challenges like competition, evolving business needs, regulation. But some challenges are very South African, like load shedding, skill shortages, and that kind of stuff, legacy IT challenges locally, etc. And it's not in spite of these challenges that customers in South Africa and across Africa are turning to cloud. It is precisely because of this, because of the economic uncertainty that these challenges provide. Many of our customers are turning towards cloud for that stability, for not having to worry about infrastructure and architecture. And what that means is that, if I take AWS, for example, we've launched our infrastructure region in Cape Town in April 2020. We already have tens of thousands of customers in sub-Saharan Africa using AWS cloud to achieve their business outcomes. They're not only migrating to save costs and to be more secure, but also they're completely reinventing how they go about doing their business and how they innovate and get new features, new products to market faster. I'll take a couple of examples quickly. We've got TimeBank. So TimeBank, South Africa's first fully digital bank, they're all in on AWS, running out of the Cape Town region. They recently expanded to the Philippines, also on AWS, leveraging that global infrastructure, and they continue to innovate and provide new products. We've also got Old Mutual, who is many of you will know, is actually a 178-year-old insurer, and they, over the last year and a bit, migrated the entire on-premise estate into AWS, and they run in a mixture of in country in Cape Town as well as in Ireland for pretty much all of their workloads. Now, these customers, the ones I mentioned and many others, are looking to cloud not just because, like, you may think it's mainly due to cost. Yes, some of the conversation starts out at cost, but we see more and more customers are targeting benefits around agility. How can you do things quicker, not having to rely on buying hardware and refresh cycles? How do you get access to more scaling up and down as you need without worrying about how much you have left in terms of infrastructure? And then how do you innovate and get access to the latest and greatest services without having to deploy or build all of those on your own? And of course, when we look at cloud, and I'll use AWS as an example, security is our top priority. So we allow customers to be able to run more securely than they could on-prem. Okay. And customers are turning to us not just because of running virtual machines in the cloud. That's kind of what cloud computing used to be back at, I'd say, like 2006. But there are many, many more services that cloud now brings to you and offers you. You still have the opportunity to use core computing services and compute, storage, CPU, core databases, but that's only a very small subsection of what cloud actually has to offer. In the cloud, you've now got services for application development, for things like DevOps and developer services. You've got purpose-built services for analytics, for mobile services, for IoT, machine learning. It's in fact, AWS has more than 200 fully featured services, and there are that many because that's what our customers are looking for us to provide to them so they can innovate faster. They don't need to do these things from scratch. I'll give you an example. If we look at the machine learning space, now you could go and build your own machine learning models from scratch. You can use things like TensorFlow, PyTorch, or you can go a level up and go, I want to use AWS tooling to do my own model generation and use things like Amazon SageMaker, which is the core foundation of machine learning on AWS. Or if you're not a data scientist, but you want to inject machine learning into your application, you could go and do things like, I want to use Amazon Personalize and do hyper personalization just by using APIs and passing parameters instead of building your own personalization model. Let me give you a quick example. So in the news earlier in the week, I was watching some news on one of the YouTube news channels I watch, and I came across Smile Coaching that's now in Japan. And yes, like in post-pandemic Japan, the masks are off. They're struggling to readjust to actual society. So now they have these things called Smile Coaches, and they're helping people to readjust. Now, if you wanted to move quickly, and let's say you're in the marketing division of your company, and your company has decided they want to take advantage of this craze in Japan and either be top of mind or actually provide some sort of offering, using cloud, you can experiment quickly. So let's say you took 2 application development services on AWS. You've used a service called Amplify to generate using reusable components and drag and drop UI. You've created a mobile app quickly. You've now got an app in days with full development and testing that you can roll out. You then go, I want to use notifications and geolocation services. Guess what? You can just use APIs and pass data to enable that functionality. And then, because it's smiling, you want to detect whether people are smiling, quality of their smile. You could actually use AI or ML services to detect smiling faces and to what degree they're smiling, or even generative AI to create a smiling version of a person, or to do text translation. And my colleague from the industry, Ridwan, will take you through some examples of how generative AI can work. But all of the major providers now have their own generative AI tooling. At Amazon, we've got Amazon Bedrock, which is gives you access to some of the generative AI services, foundation models. And if you really want productivity, you could even use code generation tools like Amazon Code Whisperer or ChatGPT to generate some of the code for you, but just beware what you use it for. Make sure you test it properly as well. So just to give you a sense of where cloud infrastructure is, AWS, for example, I mentioned we created the region in Cape Town in 2020 at launch. That footprint is expanding globally at a rapid pace. We're now we have 99 availability zones, 3 of them in Cape Town, and we're expanding in different territories. The ones I've highlighted in amber here are going to launch soon, and that is an ever expanding footprint. And the regions, I'll give you just a view, and a lot of the providers work in a similar way. In Cape Town, for example, we have 3 of these availability zones. They're each geographically separated with high-speed connectivity, own independent power supply, water cooling. That means you could use a single cloud region to have high availability across 2 zones and maybe disaster recovery in a third. And traditionally, most of cloud workloads, a lot of the services I showed you earlier, they operate in the region itself. But we've recognized that computing is not only required in those central regions, and then for low latency data processing or data residency stuff that needs to stay in a country that doesn't have a region, we have IoT services and robotic services that are at the edge. We've got rugged edge devices like the AWS Snow family that can operate with compute and offline storage down in a mine, for example. So you've got things at the center and then at the edge, and then in the middle we have services that let you operate in your own environment. So something like an AWS Outpost is our own infrastructure that you can get in and run in your data center, but it's still AWS run and managed and maintained. If something breaks, AWS fixes it. We've got something called local zones, and one launches in Johannesburg soon. Our region's in Cape Town, but we've got Johannesburg, we've got Nairobi in Kenya, we've got Lagos in Nigeria. These effectively work with the AWS region, and they give you compute and storage in a very local area. So for example, a customer like Discovery in Johannesburg will be able to run compute and some edge services in the Johannesburg local zone, while their core workload sits in Cape Town. And then of course, for customers who are like VMware customers and running VMware on-prem, you can actually run VMware services in an AWS region or in the local zone or on the outpost. So you've got lots of different options. Cloud coverage is not just a VM now running in a centralized region that you have to consider. It's all of these services that I showed you being able to run both in the region as well as at the edge or somewhere in between. So I hope that gives you a bit of a view about what cloud computing is about. It's much more than just virtual machines running not in your data center, but in somebody else's data center. It is more on demand, yes, but there's a lot more services and features than just running storage and compute. And if you have time, I'll post a link to this towards the end of the webinar. But if you have time, we released a few weeks ago an economic impact study for AWS that shows how we're investing in the infrastructure region in Cape Town and what impact that has. It's more than just infrastructure. It's about the job creation. It's about the partners we're creating, the investment into skills in the country. I'll share a link to that. It's really good reading. And if you're interested in partnering with us on any of this, you're welcome to reach out to me on LinkedIn or drop me a mail. LinkedIn's probably better. I've got tons of email. And yeah, that was just a quick overview of what cloud is and where we are going. And with that, I'll hand back to Sean to introduce the next speaker, who will take us also through some of the hands-on generative AI services.
Thank you very much, Terence. I'd like to now introduce our next speaker, which is Mr. Ridwan Basadin, who's a senior data and AI specialist with Microsoft. And let's just see why everything is so slow. Ridwan Basadin is a seasoned IT professional with 30 years of experience in various domains such as technical engineering, sales, and marketing. He has been a programmer since high school and started his career as a developer. He spent his first decade working for McAfee, a leading security company. He then joined Microsoft, where he has been for 20 years, taking on different roles and responsibilities. His current role involves helping customers leverage the power of data analytics, machine learning, and AI to create business value and solve real-world problems. He is a proud South African eager to share his insights on ICT's challenges, opportunities, and impact in Africa. When he's not coding or exploring data, he enjoys spending time with his family or playing his guitar. Over to you, Ridwan.
Hey, everyone. Can you hear me? Just let me know.
Yes, perfect. Thank you.
It is such a pleasure to be talking to you guys. It's the first time I'm addressing you, I think. And I hope that it's not the last. I think I'd really appreciate coming back. But back to my talk. Can you guys see my screen?
Yes, all good.
Yeah, cool. So what I'm not going to be talking about, as Terence mentioned, is I'm not going to be talking about how you can run your Autodesk and MATLAB, scale it out into the cloud, and you need a beefy machine that's going to spin it up and all of those kind of things, or you want to grab some IoT information and do that kind of innovation stuff. I'm going to talk more to what you can expect in the next couple of years, starting I think this year, and how you can use this amazing technology to, I guess, compress time and make your life a lot easier. So that's my talk. It's going to be more about supercharging your productivity with the power of AI and of course data. And before I start, I wanted to give you just a quick brief view on where we are as an industry, as humanity. Well, we've invented these things called AI and machine learning over quite a long time period, if you look at it. And then something happened last year when the OpenAI organization released ChatGPT. Now, OpenAI and Microsoft has a very, very close relationship. Actually, our missions are very closely aligned. OpenAI is about empowering humanity with AI, and Microsoft is about empowering every person and organization on the planet to achieve more. So very broad, very big ambitions, and they kind of merge together. And so we're in quite a deep partnership with them. But this generative AI is just something that's totally different. We're now seeing that AI can be used to instruct different types of models in the background and actually generate content that typically a human being would generate. And so what this AI, if you really look into it, there's really three different kind of models that we're seeing. And then within that, you see a whole bunch of other things spawning. You have the GPT model, which GPT-3 is generally available and GPT-4 is being rolled out. But basically what it is all about is that you can give the AI a prompt and it will give you back content. Like write the tagline for an ice cream shop, and the model will go and give you a tagline for an ice cream shop. Or you can say, write me 100 taglines, different taglines for an ice cream shop in Johannesburg, and it will go ahead and do that. Unrelentingly, without any time you wanted to do that, it will do that. And then you've got the Codex model, which actually is quite interesting, I think, for electrical engineers, because some of you guys program circuit boards and things. And this is a model that is all about code. So you can see there the prompt it's actually showing the prompt is what you're giving the AI. So it's actually giving you the schema of a table. Like there's a table for customers and the columns is all of these columns. Now, with that information, write a SQL query for all of the customers in Texas named Jane. And the response is select star from blah, blah, blah. Okay. Now you might think that's kind of okay. But think about the applications of this just in the database world. Because now you don't have to have static queries. You can have humans asking the AI to do stuff. But also, it doesn't stop with SQL, any kind of language that you have, even to the point where you can make up languages. But code, being able to generate code, but also to be able to take code and generate English out of it. And we see that in many of the scenarios now where we are in the security space, where you can give the AI a bad actor script and actually help, it will actually decode it and backward engineer what it's actually doing in English. And then you've got this DALL-E. DALL-E, you see the prompt is, I want a white Siamese cat. Now it gives you back an image. So this is all about image generation. Now what's interesting here is that you won't find this cat anywhere on the internet. It's actually been generated, and you could do it as an oil painting and so on. And so these models can help you do some amazing things. And I wanted to maybe start off with just a quick demo. For those of you who haven't seen this stuff, maybe you've heard about it. But for those of you who haven't seen this in action, it's actually quite amazing. So what I'm going to do is I'm going to switch over here to my ChatGPT. I hope you can still see my screen. If
Yes.
you don't, please let me know. So let's do something simple. So when you say that these things can do amazing things, let me give it an exam question. So in this exam question, it's I have an ohm resistor, blah, 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 connected to another resistor, and this is the amps and things like that. What is the value of the unknown resistor? So this is an exam question. So it should understand certain formulas that you guys understand and be able to unpack it and then plug in the values into that formula to be able to get me to my answer. And my answer is actually twofold. What is the value of the unknown resistor, and what is the voltage drop across each other resistor? And so it's given me the answer, 3 volts and 0.5 volts. That's quite scary, I think, if you really go into it. The other thing that you could do here is you can make it play electrical engineer. So I'm going to create a new chat here, and I'm going to say, you are an electrical engineer working on a project to design and implement the energy efficient lighting system in a residential complex in South Africa. Explain the steps you will accomplish and adhering to the relevant standards and regulations of the country. Do you understand? Okay. And he says, yes, I understand. But guess what? It's going to give you some step-by-step processes around things that you should probably be looking at and considering. Now, this can be both kind of annoying, but also as an electrical engineer, be like, well, I didn't actually think of that. So one of the cool things that AI can help you do here is that it can help you think about things that maybe you didn't think about, and in terms of adhering to certain things and certain best practices. So I'm going to take that and I'm going to say, okay, something a little bit more specific, because it's given me, and it's still continuing, my goodness, number 10, and it hasn't stopped. And you can see all of these things that I should be considering. But let's take something like, I'm starting a new project and I need to gather requirements, right? So that's one of the things it actually recommends. So let's say I need to now go in, help me draft a list of requirements together for a new complex in Umhlanga. And now I'm going to go ahead and ask it, and it's going to help me draft some of the requirements. Maybe I need to send this to my customer. Maybe I need to just get a view. Maybe I'm not on top of my game, and it's now giving me a whole bunch of things that I need to maybe consider and enter into my proposal to the customer around my requirements and look super professional. And see, it's still going. It's giving me a lot of things to remember, a lot of considerations and things like that. So this is the kinds of things that we're talking about, right? That these generative AI models can help us with. So what I'm going to do now is maybe for you to consider this, right? In terms of now looking at your productivity, perhaps think about embracing this, right? Because with this technology, you could have a co-system that never sleeps, that never is tired, that's always on their game, that's always maybe improving, to do the mundane, repetitive tasks that, you don't really care about, so that you can focus on the most strategic aspects of your job, maybe the relationship with the customer, maybe you just love doing the hands-on stuff, maybe, yeah, but delegating the things that's repetitive, that you can still, that what you saw, maybe not the way you write, but you have a draft and now you can keep on going, and actually editing it out. And what we're seeing as Microsoft, right, is we're seeing that perhaps that type of capability should exist in the tools that we're already using. And maybe it should be baked in to a lot of the things that you're perhaps already using the cloud, because that thing is in the cloud. It's sitting on a data center somewhere, and actually doing all of that compute and analyzing the queries and so on, right? But what you're going to start seeing is this, and we've announced this Microsoft 365 Copilot, and you're going to start seeing Microsoft, and I think a lot of other organizations start embedding these kinds of technologies, bake it into the solutions that you're already using, and allow that generative AI to be that co-pilot that's always helping you, excel and be creative and be analytical and be more expressive and be more productive, and so on. Right? So I wanted to give you maybe a taste of some of that. So you have here the power of your words that can maybe be used to do something, like for a meeting, preparing for a meeting. What do I need to do? Let me maybe look at what's the meetings that's coming up. Let me maybe sort of prepare that with the Copilot, draft the product announcement, draft the something or use something that I've already created. Take this document, put it in a spreadsheet, or take this document and make a PowerPoint out of it. Those kind of things. This AI can do those things. Creating presentations, generating that input for you so that you can go in and refine it later on, analyzing the data in the spreadsheet that you're kind of using. But now you've got that Copilot, which is cloud-based, but you're right on your laptop. All you need is an internet connection, and it can start going and help you accomplish the tasks that you, don't just, maybe you don't have enough hours in a day, but now you can have all of those hours in a day. Maybe you can accomplish a lot more than you haven't in the past. Analyzing things like data, creating proposals, creating timelines, agendas, using your agenda. All of these things are all words, and you can use that power of that words, give it to the Copilot, offload a lot of the tasks, still refine it to make sure that it's accurate and make sure that it really reflects your ethics and humanity, but without the grind. And maybe to help you with a quick story here, imagine you're an engineer. You come up from PE to Johannesburg or Durban. You've got a sick family. The wife's in bed. You're taking care of the baby. Your mind's typically, a hub of ideas. You need to put out a new proposal. You're blank. You've got no creativity. But you can turn to your Copilot to draft out the proposal, draft out the piece of work that you need to do to take care of your family, to balance your professional, personal life, and in the midst of all of that chaos. And so what I thought I'd do is take just like the most boring product that you've ever had, Microsoft Word, and see how that could potentially work, these kind of things potentially work inside of something like Microsoft Word. So for example, you could here, use this Microsoft Word empowered with this Copilot. Imagine you're creating now a proposal to a customer, and you now don't have the time to, do that proposal. You can ask it to help you draft the proposal. In this case, you could use maybe your previous meeting notes that you had in an interview with a client, some documents that you have, and just like that, it can go ahead and actually use that as input for the proposal. That's pretty cool. So now you've got a draft that doesn't look cool. You had a previous proposal, and you want to actually use that previous proposal to make sure that the right images are there, the right designs are there. So you're putting the designs, I'm telling the Copilot, pull the designs from this previous proposal and put it in there. Now it's got my logo, it's got all of those things. And you can see on the side there, it's suggesting to me, perhaps add a summary. And so I can go ahead and say, just click that button and it goes and adds a summary for me. and it says, suggest ways to improve the document. And it says, okay, you could probably add a frequently asked questions. And it goes up and adds a frequently asked questions. And now you've got a header. You've got an edge, and you increase your productivity immensely. It's quite amazing, I think, in terms of this is the kind of things that you're going to be seeing more and more of. And that's in the cloud, but the cloud is invisible. I think that's very cool. So I wanted to keep it at that level. Of course, I've got a lot more demos. I've got a lot more things I could say, but I hope that gives you maybe just a taste around, how you could potentially use the cloud, not just maybe running your MATLAB in a cloud data center, but actually using the output of this generative AI, this co-pilot mechanisms to be able to excel you, to be able to analyze data better, to be able to get work done, and to be able to be on top of it again. Thank you so much.
Thank you very much, Ridwan. That will definitely make everybody's lives easier using that software, the Copilot. I'd like to introduce you to our next presenter, Mr. Rendani Sivangani. He is a senior solutions architect with telco, media and entertainment in the EMEA region at Red Hat Inc. Rendani began his career at MTN as a graduate student and fulfilled several roles as a network transmission engineer, switching engineer and network engineer before moving on to Ericsson and then to Vodacom. He worked at Amazon Web Services as a solutions architect in the telco vertical in the EMEA region. Rendani is passionate about positively impacting his community and volunteers his time and resources to various community development initiatives. He is committed to social justice and using his expertise to help others, particularly in the 4IR emerging technology like cloud computing, where he holds more than 6 AWS certifications. Over to you, Rendani.
Thanks, Miss. I'm just gonna get into my camera. I can share my screen. Okay. Okay, my web camera just disappeared. Now I can get it. Okay, thanks. Something blocking me here. Okay, please let me know if you can see my screen.
I'm just waiting for full screen. Yes, there we go. Please proceed.
Okay, no, cool. Thanks, Monique. So, good evening, everyone. So today, I just want to then share with you one of the product, which is the Red Hat OpenShift. Looking at how can we actually be more productive with our work, as we know, now the technology where it's currently moving now, we do have a number of technologies which is happening in the cloud. We do have a different cloud providers, especially also here in Africa, where we are limited in terms of resources. But we still also see the resources where you still have to do some work. Is either on your own premises because of maybe you still have some investment that you've made, or you've got some issues which is forcing you to have your data sitting on premise, things like the data sovereignty issues. So the current enterprise IT that you can currently see right now, it will be looking at something like this infrastructure where we have our application running maybe on a bare metal or in a virtualization, and then a private cloud and a public cloud. But again, time and again, we always see the increase and then to move and then the application also closer to the user, where we're talking about the IoT devices. Currently, we're also talking about the connected vehicles, where you need to always be connected. So those are the applications that you need to move it closer to the user. That's why we find ourselves adding another infrastructure, which is in the edge. So the edge, that way it can actually give you that kind of capabilities for the low latency and the fast response. So with OpenShift, and then it currently help you with in terms of making your application and then much smarter. But again, as like an engineer or an application developer, you might be also interested in the value that you're gonna create with your application. You might not really interested more into how to manage and then your infrastructure, how to manage and then the different type of an infrastructure. Because like right now, you might be like interested on gaining some values which is provided by another cloud provider, or you might be interested in gaining some other features which you need to do it and then on-prem because of you need the data net closer to the certain application on-prem. So you find yourself like with a mix of like a different requirement that you need to fulfill, and having those kind of a mix of a different requirement to deliver then your application, it can actually hinder your production. It can actually hinder like the progress that you need to actually move faster and then to get to the market. So with OpenShift, it kind of like help you to put everything together and take most of like and then the administrative work and then that you have to go through managing your infrastructure, and then you move it and then to OpenShift. So as you can see, like here on an application portfolio, like here we've got an AI, ML, and all those kind of things, and then serverless, and then most of the application are still developed using Java, and then we still have a more that are on .NET. So you do see those kind of a mix and then portfolio and a different ISV. But at the end of the day, you do have like a people that they need to manage this application. You also need and then the right skill and then to run your application in the cloud or on-prem. So that can actually like mean that all the time, whenever that there's a change in your infrastructure, you need to go back and retrain, and then the people that you have, you need to retrain the skill, the policy of like how you develop your application. It will always change because of like there's no consistency. So this is like, and then what is like currently happening. If I can ask like what's like, you might have some questions and then in your infrastructure, in your environment, that you can actually see what is currently happening. So how do you actually deliver and then your innovation faster and then in this kind of a complex way, like I've shared with you like a number of things. So the development of your application, it will be like looking at to say that from end to end, you need to actually start architecting your application with a security and then in mind. So the security is like the top priority, because like now as we move into the connected world, everything is becoming more connected. One aspect that you also need to put it first is the security. So as you can see that moving from the left and then to the right, and then the security, and then it cut it across all the different platforms. So with OpenShift, this is where like it can actually like really help you to achieve that kind of an efficiency and the consistency and the flexibility across all the infrastructure that you have. So as you can see, and then from the bottom there, like which you're showing, like in regardless of which infrastructure that you are actually working on, you'll actually able to achieve and then that kind of a flexibility and the consistency and then efficiency across the different environment. So taking into the hybrid and then approach, and then because like as you have said before, like because of like the business need or business requirement, you might find yourself in a corner like where, or in a position where you need to take and then the hybrid and then approach and then for your infrastructure to deploy and then your application. So that's where like there you see there at the top, and then you've got different tiers application which you can actually get managed, and then in a different environment consistent without you really worried about how your application is gonna get to be supported or who will be like actually monitoring at what side. So as we can see, like and then modernizing and then our application across and then different infrastructure, it like really require more. But like what you need to achieve and then for you to becoming more profitable or to go to the market much quicker, you actually need the speed. Then once you've like deploy and then your application, again, the issue of the security is always like one of the point. But now I'm not gonna go through all of these like, components, but as you can see that you'll actually need to, you will actually able to achieve the scalability, the stability, because of in regardless of which environment where you are deploying your application, and then you really need to achieve this. The nice one which I also like around here is around the portability, because like right now, if you can architecture your application based on a certain environment, it will mean that like for you to take that application to maybe on-prem or move it and then to on-cloud, you might need to modernize your application. That actually really mean time for you to do that. So with like an OpenShift, it kind of like give you that kind of the portability, because like its efficiency, it's like seamless and then across all the platform. So whether you deploy your application on cloud, on-prem, and then edge, then you're gonna find the same type of like an application. So what is like, and then you say like now when it's coming to the technology. So OpenShift, like it's currently what we see happening, most of the companies moving into microservices. So microservices, you can actually like architect and then your application, and then using the Kubernetes, and then Kubernetes, which is like an open source, and then OpenShift, and then they also use and then Kubernetes, which is also based and then on open source. But now when you go through the route of like, and then with the Kubernetes, it means that you have to do everything and then by yourself, creating the environment and the infrastructure. But OpenShift is a platform and then as a service which can actually like help you to deploy your application, and then right ahead, and then will take care of like and then the platform, or you can actually like and then manage and then that platform as your own. So it can come in two ways, which can be self-managed or manage and then platform. So when you have it at a managed platform, it actually like really help you to make sure that your application is, you only focus on an application and then we take care of like an infrastructure. Or you can actually do that, but your application, it will be seamless across all the environment. So one thing that like, and then it also give, it actually like give you some time back, because like as much as you know how to use and then to deploy an application in this infrastructure, you're not gonna be like really focusing more on to managing the infrastructure. You're gonna be focusing more on innovating and developing more and developing and then your application. So OpenShift is actually available also in the different cloud providers, like as you can see from AWS and then Azure, Microsoft, and then IBM and Google Cloud. So it's actually available as a managed service. So let's say, for example, right now you want to get started and then with OpenShift, and then you start to see like it's OpenShift as a platform, as a service. You can just actually like log in into the AWS, where you can just choose and then the OpenShift as a service, and then you can actually start and then working on it. So some of the benefit which is actually come with this environment, your billing is not gonna come and then different if you are currently using and then your cloud provider, and you also get the opportunity to try it and then and see if it works for you, since like the module is like a pay as you use. So you don't have to like really have and then the subscription and then for OpenShift if you're gonna try it and then in the cloud. So whenever you deploy your application and then in the cloud or anywhere in where you can deploy it on edge or on-prem or bare metal virtualization, it's gonna be the same as across all these kind of a cloud provider. So if you have to choose and then this maybe one of two cloud providers and then for your organization, it means that like OpenShift, it can actually really help you to make your application to be portable across all the cloud providers. It can actually like really help you to make sure that you don't necessarily need to retrain more engineers and then for the different provider for managing the application, but you can use the same. So these are some of the benefits that you can actually get like when you're looking at the managed service and then using and then one of like the cloud providers that we partner with here. So that will give you time back and then for you to focus on innovation, and you can accelerate and then your time to value and help you with the flexibility and then across and then the hybrid cloud and the multi-cloud. Then of course, like when you are operating in different cloud, it's gonna come and then to your operational cost. So but now with OpenShift, it will help you to actually like manage and then your platform much better, more efficient, because now when like you either go to AWS for OpenShift, and then we do have an option like where it can actually be managed by AWS and right there, and then you focus on your application. So what are the benefits and then that we also see, like especially now on the C-level, like the benefits and then the executive, they will also like it because of like it actually really help them to go to the market faster and innovating, and help them in terms of like a saving cost, because now if you really have to hire a cloud engineer or you need to hire someone with a certain skill, it can actually really take a minimum of like 3 months and then to 9 months for that person to start delivering their result in an organization. So, but like now, when your application platform is actually being dedicated to other organization to help you manage that, that means that you can focus on innovating, and that can be like really time to help you with the time to market. So as you can see that, like, and then for the developers, and then it actually like really help them in terms of like the development life cycle, which it can they speed up and then the process, because of they don't really don't really have to manage the infrastructure. And then the operational as well, and then there's also some benefits that you see, and then infrastructure and the security benefit, because we are always like making sure that we are taking care of the security, making sure we're scanning the vulnerabilities. The other benefit that you can actually see that is like actually like having the SRE, which is like the site reliable engineer. So the site reliable engineers, they are really not cheaper, and then to actually source one and hire them, and then to actually fill and then that skill, especially when we're looking in Africa, where we are actually like even in the world, we do have like a skill gap all the time. There's always like someone who's looking and then to fill the certain position. So having like this application or running your application in OpenShift managed service, it means that you also benefit and then from those SRE that you don't necessarily need to go out and advertising their role and then you go and hire them. So in like, and then kind of like in summary, showing like what are the benefits which is coming, and then with this managed service, it's like help you again with the consistency where like your IT operation and the developers, they don't really necessarily need to learn a different platform to deploy and host and then their application. And of course, the flexibility is also an option which is there, which is like now if you have your application running on-prem and then tomorrow you decide to move to the cloud, then you do have that flexibility. And then there's a need for you to be on edge. You also do have that flexibility where you can actually move and to the edge, and which is actually giving you more opportunity for you to choose from different partners that we're partnering with. So I would like to thank you and then for this opportunity. And if there is some more engagement, and then feel free to reach out to me, and I can actually like really help you with like more engagement and see how OpenShift it can actually really help you to innovate and try like your application and deploy your application across and then the different environment. Thank you for your time.
Thank you, Rendane. Gentlemen, thank you very much. Thanks to Terence, Ridwan as well for the insightful presentations. I've got just a few questions to kickstart our discussion around the productivity improvements that are brought about by cloud computing. Maybe just a first question to Terence, just to break the ice. I think initially when you started your presentation, you emphasized the advantage of cloud computing in quickly deploying apps without having to struggle around acquiring infrastructure and so forth. And I think I come from an electricity background, and in moving with the times and trying to modernize the electricity infrastructure, one of the things that we need to do is deploy a lot of connected sensors across the power system to get as much data as quickly as possible. But every time the issue is around acquiring enough computing to deal with that. Do you have any thoughts around using and quickly deploying systems in mining, electricity type industries as well?
Yeah, so I think the vast majority of workloads that we are seeing, and remember I had the slide up that showed what can run in the region, things that we can do at the edge. Depending on what you need, there are services available for you to run in a disconnected mode, in a semi-connected mode, run things locally closer to your office location, and then in the infrastructure region itself. And I think there is generally a misconception that I need to keep these things close to me because of latency, etc. But we've got, and if I look at all the cloud providers that are in the country, there's high-speed connectivity that you can get, dedicated connectivity, dedicated services that let you connect in and run workloads that are quite highly very latency sensitive. You can actually run in the region. And then for services that need to be in a disconnected site, we've got things like I mentioned earlier, AWS Snow Family. That's we've got these things called snow cones or snowballs that are effectively almost like a very rugged like PC. Remember those old PC cases? It's like a very rugged big version of that has high density storage and compute and can operate in an offline mode. You can even run things like Lambda, which is like our serverless functions. You can run those in those devices. So there are many more options for compute, even if you can't get to like an AWS region. And those services are evolving all the time and becoming more pervasive. So that's just around areas where you can't get to. Now, I know you're also talking about things like energy and how getting enough electricity. I think for many of our customers, it is becoming a challenge. You've got to keep your generators going when there's load shedding, right? And for AWS, when we invested into the region, into South Africa to create that region, we were already aware of all of the challenges around energy security. And when we decided to open up that region, we had already had in mind that we may need to run off grid for an extended period of time in a disaster kind of scenario. So we've taken measures to make sure that we can run continuously even in the event of extended outages. And we've got like enough diesel generation capacity, various levels of backup. And what that allows you to do is, as a consumer, you don't need to worry about your data center going dark. You run on AWS, we're taking care of that for you. You can worry about the other things like Ridwan was talking about in generating content and ideas and actioning them, or Ndani was talking about getting solutions out faster and making sure that you're taking care of the engineering. You don't need to worry about the underlying infrastructure, the connectivity, the electricity. We're taking care of all of those things. And very often when you're running on cloud, because of the scale, you're getting better security, and you're even getting far more sustainability. Energy consumption running, for example, in an AWS region in Europe is significantly lower, like 6 to 10 times lower, depending on the use cases, than running it in an actual data center somewhere else in Europe. So you've got all of those benefits and nearly limitless capacity, because unless you're running something very specialized, like those really large SAP HANA databases that need specialized hardware, for the majority of things, there's enough capacity in an AWS or in a Microsoft environment that you're virtually limitless. And if you're doing something that's really going to push the limits and exhaust all of the capacity, a little bit upfront planning and letting the provider know will organize and reserve that capacity for you. So that takes away a lot of the like traditional thinking around capacity planning, literally keeping the lights on and running the environment, and you can focus on the innovation and the things that need to change.
Yeah, no, I think that's one for me that makes cloud computing so attractive. It's because a lot of us within engineering are domain experts and do not necessarily always have the expertise to lay out a computing network or a platform and so forth. And I think in that sense, it does improve productivity when you don't have to worry about that. Thanks for that response. I'd encourage the audience as well to post their questions on the chat and just mention your name as well and who you are directing the question to. Ridwan, you had a very interesting presentation on the engineering co-pilot, I'll call it that. And I think a lot of engineers would be skeptical of particularly co-piloting with a piece of software on solving complex engineering problems. What I'm interested in knowing is that how do you train these models to actually deal with, you showed us the Ohm's law, for instance. There are other more complex engineering formulae that one might be using from in day-to-day work. How do you update the platforms to ensure that they are able to have the most recent engineering knowledge and also reliable answers, if I may say that? Because if you would rely on it, surely you need some integrity on it. If you could just share your thoughts around it.
Yeah, look, I think where we're at is this space is moving very fast. But it does have challenges, and you highlighted some of those challenges. And we've actually seen, if you look at some of the articles being written around generative AI and first couple of conversations that sometimes people have had, they notice a couple of things where the AI can hallucinate stuff, right? It can think. It was a very cool example given to me by one of our engineers. Is he asked the AI to write some code in a language that is internal to Microsoft, was never trained on, and it went and did it, but it imagined it. Okay. It imagined it, it hallucinated what it thought it would be like, and so that's very, very funny, but also dangerous, right? And so what you don't see is how you actually, and we didn't have time to do that, right? If you look behind the text and behind how the models are created, it's actually multiple models. It's a language model, but there's also decision models. There's also like a whole bunch of other models that you're not seeing. Even the prompt as it comes in, there's a model that runs to make the prompt cleaner. That you gave it, so you can put spelling mistakes in it and so on, right? And then it goes through, it's like lots of different stages it goes through, and it could pull the different models. For example, you could give it a PDF to reference that has some rules guidance for electricity engineering or whatever, and you could ask it to reference that thing to give you a more accurate information back, right? And so what does it take to look at a PDF? Well, you need something that can actually scan and OCR the PDF and get the right data and so on. And so there's multiple models in the background that you're not seeing. So there's reasoning models, and there's versions that's coming out, like the ChatGPT 4 is a lot better at reasoning than 3.5, for example. But you have to. You can't, the onus is still on you as the pilot to make the final decision around this is accurate. Well, this conforms to my ethics. I think that's the way you should think about it. So I'm not saying that it's going to replace like a calculation in MATLAB. No, it doesn't make sense, right? You rather do it in the product that makes absolute sense for you to do it. But what I'm trying to show you is what happens when you merge the two. When you have super awesome accuracy, but the code being generated gives you a heads up to what you're actually trying to achieve, and that's where we're seeing things going. And so take out the things that are human and the judgment of whether this thing is right, but let use it for what it's great at. Like if you've got a data model and you want to express that data model in whatever makes sense to a dashboard of some sort, right? And AI can do that. It can give you a good starting point. And then you could say, well, I want to change this and that and add this and that. And I want to create a formula that does, and it can create the formula. Yeah. You still need to check if it's accurate. So there is that tension between it. So you're skeptical, the skeptical nature of the engineer is absolutely valid. Absolutely.
Yeah, I'd imagine in any case, when you correct it, it does learn. So it does accumulate the knowledge over time, nonetheless. And the next minute, it's much better. Rendana, I just want to bring you also into the discussion. I think you touched on security of the cloud. And again, it's out of skepticism from the type of industrial environments that we come from. I think Terence mentioned talked about latency sensitive applications. And every time from an electricity utility perspective, especially in these POPI Act days, the moment you think about putting customer data on a cloud somewhere, then you become a bit worried about the security thereof. Could you just give some thoughts around the robustness of security on cloud applications?
Okay, cool. Thanks, Sean. So, like when we're talking about security, especially like in the cloud, especially let's talk around in the cloud. We've got the model which we call it, and then the share responsibility and then model. So the share responsibility model, it means that you as a customer using the cloud, you've got a certain level of responsibility, and which is the same, and then for AWS is the same, for Azure for same, for any other cloud provider. So when you focusing on like making sure that your application is secured, then the cloud providers, they focus on making sure that the infrastructure running everything and then it's secured, which can be like the physical security, or we can be like making sure that and then patching the OS and then which is running the VM, which is the VM or the hypervisor running all those like VMs in the cloud. So again, you do also have and then the OS, which you always like have to patch, and then like coming and then from Red Hat, and then which we've got like one of like the most used, and then Linux, which is the Red Hat Linux. We also like make sure that we are taking care of like a patching that. So like if you go there and then you're using this software as an open source, it means that like that responsibility is gonna lie and then on your shoulder. But now when you look at the partnership that Red Hat and AWS has, they've been like when you go to AWS, you will actually able to see the Red Hat applications. You're also able to see the Red Hat OS where you can put it in your virtual machine. So the security part is actually being taken care of like in an infrastructure that you are using. But for you, you need to actually make sure that you are responsible for the security on your application level, and you actually need to understand the type of like the privacy which is needed, and then for the different data. We can touch base on like and then how to make sure that like you comply and then with the POPI, like as like Terence did share like a time bank, which is like a very sensitive data which is sitting and then in the cloud. So the law does allow us and then to use the cloud, but you just need to understand what you are responsible for and what does the cloud provider is responsible for.
Yeah. All right. And then in terms of this is just an open question to all of you. You can pitch in and respond to it. In terms of AI itself, it's a fast changing field, and I'm glad that in fact Ridwan touched on 3 modules that are already available. One doesn't have to start from scratch to train it and build it and get the data to train it, and so forth. Because in my experience is that by the time you are still learning how to train the model, something else has come up and solved your problem. So I just want to get all your thoughts around AI models that are geared towards the engineering applications that you've seen implementations of, or that you have as products within your spaces. If you could just share on that. We can start with Ridwan and then
let me start with that. I mean, there's of course a lot. There's a lot, right? And what we're seeing is a lot of these AI models are already just in the products that you use. For example, the example that you gave earlier around collecting sensor data from the net, from a wide network. You know, a lot of the times in the old days, you'd have to put that in, like, let's say a CSV file, and it's a massive file because it's millisecond data or whatever, right? in these days, you could use better systems, number one. Like you could put it into a time series database that automatically has AI built in it to forecast or to look at anomalies and things like that. So there's already these pre-trained models that's very, very popular. And you should be looking and utilizing those things. And then you get the more complex ones where, you know, the vibration on the, you know, on this pump in combination with that turbine, you know, that there's an interaction that you want to train for example, right? And or dip in the voltage or whatever, right? We want to train for something a little bit more complex. What we're finding is that the ability to train those models using automated systems or asking the AI to build the model for you is now there, right? So you can go through the painstaking task of handcrafting the model, or increase your productivity. Let the AI, either through a wizard-driven approach or through text, say, you know, I want to create a model that uses this tag, that tag, and that tag, and this is the interaction to create the model, and it splits out a Python file with a notebook, and you have something to work on. Okay, you've got a heads up. Now you can go and refine it, train it, and test it. So I find that over time, that's becoming easier. The ability to create a model is becoming so much easier. And what it means is that you can focus more on where you're going to influence the model. So maybe it's a container on a Red Hat OpenShift in a, you know, somewhere on-prem, for example, right? So that becomes, it's so exciting because now creating the model is not a challenge. This is where you want to influence it. Oh, cool. We want to do it there or there or there.
Yeah, I'd assume you also as cloud providers are able to provide guidance on which modules are best for what applications. Any thoughts?
Yeah, that's like which religion is the best sometimes.
Yeah, it's a slightly nuanced view of that, right? Because what model do you use, what algorithm do you use if you're going down into the next level of detail? It depends on really on your use case and your data and what you're trying to achieve. So if it is something more industry known, industry perfected, let's take like demand forecasting, right, for sales. That's something that is a well understood discipline. We have companies like you know, like Woolies and various retailers that have done like supply chain optimization for decades now, using a version of forecasting models. In the past, it was very, you know, you needed not just a data scientist, you need somebody who studied stats for like 20 years to come and configure parameters, etc., and train models. Now, if you wanted to, you can roll your own model, or you can use a pre-built service that actually does that kind of demand forecasting. At Amazon, we've got a service called Amazon Forecast, where you can supply your data, your parameters, and you use a pre-baked model to do the forecasting. Now, if you're in a very specialized type of forecasting, that may not be a fit for you. You may want to develop your own models, and a lot of the tooling now will shared like SageMaker earlier. SageMaker, you can run AutoML, and Azure has the same. You can run an AutoML. It will run various models against your data, various algorithms, and it will give you a view of this one's actually the best based on your training data and your test data. This one's actually more suited to that data. But you've got to be so careful that you're not introducing bias into your model, that your data is representative, because otherwise you end up with things like, you know, racist language models and you know, decision making that's biased and that kind of stuff. So responsible AI is actually a huge area of interest right now, and there's actually, we've introduced into our machine learning university specific topics around responsible AI. So there are, like, if you want to go and create your own model and do that and have your own data, etc. There's all the services to support you working at that level. If you want to go and just use like forecasting, or you said you were looking for an engineering example in Amazon, in our fulfillment centers, when you order the stuff from Amazon.com, we've got like miles and miles of conveyor belts. We have these little like orange cubes that Monitron devices. They sit next to the conveyor belts and they just pick up vibrations. Now that service, based on the vibrations it's picking up, it knows there's a conveyor belt level of vibration, maintenance is due based on when it gets to a certain pattern. Now you could use a service that does that, or you could go, I'm going to do my own IoT device. I'm going to do my own models because my process is so different from anything else in the industry. And you can do all the groundwork to do that forecasting of predictive maintenance if you feel that it's so far removed from kind of off-the-shelf services, or you can just use that service that's available and tweak it. And like even with this like generative AI kind of stuff, you'll hear the term foundation models. Those are basically somebody else has put in all the effort to train the model, put in all the data, etc. Now, if you just use the foundation model and go, I'm going straight to market with that, it's going to give you any answer, right? You could go like, if I'm Capitec Bank and I go, I'm just introducing this generative model, I'm using the foundation model, and somebody goes into the agent and goes, who's the best bank? Now that model is just going to answer based on what it knows. If it thinks like FNB is a better bank, it will go to FNB for these products, right? So you've got to take those models, contextualize it with your own data, and train it to a certain extent on that, and then let it go. So it's, yeah, the technology is there. What we need to innovate on is there. You choose based on your skill set and the people you have, whether you're going to go like down in the stack and roll your own, or use something higher up and customize. But you've got to take other things into account, like training data, making sure there's no bias. Are you being responsible with the technology? And it's getting a lot easier than it has been in the past. We're relying less on statisticians and data science only, and that's become a lot more democratized. And I think what cloud's also giving you that more and more than ever before is the ability to run that a lot cheaper than you could in the past. Because in the past, if you needed to run these huge models, you'd need a lot of GPU compute and a lot of electricity and these big instances to run it. With specialized hardware coming in from cloud providers, from the GPU makers, it's now become a lot cheaper to actually run those models. And if you're in the cloud, you run the model, you train it. And training is a huge effort. When training is done, you don't need to train again. So you just switch that off. You then only need to use other instances to do inference, and you're not paying for like these tons and tons of training servers that you've used to train the model. And that's really where cloud is making a big difference there.
Yeah, I'll testify to that. Specifying hardware for AI computing in itself is a science. So if there is that computing power available off the shelf, even better. Randan, I'll just take your thoughts if you have, and then we'll move into the questions.
Okay, cool. So I think one thing that like I just want to add, and then just to have a different view, with like everything that they said, AI, it's always been there most of the time in our application. And then I'll give you, for example, on your email, then you do get some email that they go to spam. Then that was like, and then kind of like an AI, and then determining whether this email is right or not. And the fraud detections, and then from the bank, it's also another like an example. And then where like, and then we actually like use AI, where you see a lot of AI and then being used there. But now going back and then to that one, it's actually lies and then on the data and then that you have, and then to say like, what is it that I want to get out of the data, especially from the engineering side, when you're thinking about how much time can we save in terms of like a maintenance by using the predictive maintenance, because the sign they were there, but you were not aware. But now collecting that data using AI and ML can really actually save you so much time in terms of like and then knowing what's going to happen and how to plan and schedule your maintenance. And you can actually like collect all that data in terms of demand and supply in order for you to make sure that you shut down a certain plant, and then whenever that you don't really need, and then that plant, you know. So there's a lot that it can actually be done, but it goes back and then to the data and again the computing power and then that you need.
Yeah, I think you still have to engineer the solution, even though the tools are there. All right, I'm going to go into questions, and we've got quite a few, so let's just get into it. From the first one is from Ndibuo Makondo. I think it's for you, Terence. You're the only one who has the AWS shirt on. All right. So it says, has AWS added infrastructure to support training, fine-tuning, and deploying of foundation modules? I think you did touch on that.
Yeah.
If you still want to add that.
Yeah, absolutely. So we've got specialized services and specialized hardware for things like training and inference. So you know, the kind of pattern of compute under the hood is different for when it comes to training versus inference, and we've got specialized hardware and services to do that. It makes it a lot more affordable, but also the time to train is quicker, and that's there for both the like generative models, and as well as available to you for your own custom models. So yeah, I think if you're not sure what to use or what service to use, what instance types to use, you can always experiment, because you can you know, switch it off if it's not the right one and try different ones. But you can always reach out for guidance to an AWS solution architect. And also there's a lot of blogs on the topic on our blog site, where you can look at what people are doing and what they're choosing for what type of workload.
Yeah, and I guess it's the same for even Red Hat and Microsoft as cloud providers. I'd imagine part of your work is to update your processing power from time to time to accommodate the exploding size of modules these days. Ridwan, on to you next. While you were demonstrating ChatGPT, there's a question that came in. If the app can handle Kirchhoff's law instead of Ohm's law. I'm assuming that's the case. I think you are muted, Ridwan.
Yeah, no, I haven't tried, guys. I'm not an electrical engineer, you know that, right? I'm a computer science guy. But I do tinker with the Arduinos and what Raspberry Pis. But now I don't know if you have a question that you want to ask it, we can do it live and actually see if it handled it well.
Yeah, no, I think it would, because in any case it relies on the data that's on the net and previous learnings. Rendani, there's a question from Ndibuo Makondo again. It says, what guarantee do you have that the cloud provider will not use your data on the cloud? So what guarantee the end users have?
So like as you can say, anything that get deployed and then in the cloud, then you are responsible and then for your data. There are also different type of like encryption, where like now I've seen AWS, they've also introduced and then where you can actually keep and then the encryption on-prem. So like now once you've encrypted and then your data, no one can come and then decrypt and then your data. And the cloud provider, they are not really looking into like and then someone's data or customer's data, but they are actually looking at an infrastructure. So that one is not like their responsibility and then to look at the application. They focus and then on the infrastructure. So there are a number of like encryption that you can actually and then apply and then in the cloud. I'm sure like also Terence, you can add some there on like what AWS and then they do and then around the encryption.
Yes, so when you talk about data encryption, there are multiple ways you can do encryption. You can do encryption with keys that AWS controls. As a customer, you can bring your own key, you can bring your own hardware security modules and do encryption. And with things like envelope encryption, even if your data and your keys that encrypt that data is sitting on AWS, on, let's take S3, our simple storage service for an example, you can have your customer managed key on your side that we don't have access to. So even if we were, like, let's say the South African government asked us to hand over all of your data for something, even if we had to do that, and I'm not saying we will, we would identify that and come to you with that request if something like that happened, we would not be able to, nor would the government be able to unencrypt that data and look at the contents, because you as the customer are controlling the key. So we've got a few financial services companies who do exactly that. They control the keys, and all of the encryption happens on their side whenever they need to use that data. Additionally, you've got the guarantee that if you're using, let's say, the Cape Town region, your data is staying in the Cape Town region. It's not going to another region. I showed you that global network. The data is where you define it to sit. It doesn't move anywhere unless you physically move that data somewhere, which also means at the same time, if you want to do a multi-region approach because of like availability or DR, you've got to define that you want that data to sit in Cape Town plus Ireland, for example. It doesn't automatically move. So data residency and security, while there are things that you need to decide to do, like whether you're going to use your own key or an AWS key to do encryption, all the tools and all the functionality to do those security things like encryption and identity management, etc. All of those supporting services are there and available to you, but how you use it and what you elect to do is up to you. And of course, we provide best practice guidance, etc., but we don't force you to do encryption in a certain way or force you to use this type of method of authentication, etc. That's up to you to decide. Like Rendani was saying, it's a shared responsibility model. We give you the tools and the visibility, but the decisions you make and how you want to set up your application or solution is up to you. And down at a certain layer, like the actual hardware infrastructure, the actual data centers, we control all of that, so you couldn't even get to that level if you wanted to.
All right,
I think
thanks.
to add one there, Sean, like
Okay.
there's also in some another service which has been introduced in the cloud called confidential computing. So the confidential computing, that's where like you will actually process and then your data inside the cloud without you decrypting and then that data. So I'm not gonna really go deeper and then around that, I'm just gonna leave it there so that you guys, you can actually go and read about it. And then like around confidential computing.
Thanks. Ridwan, there's a question from Mr. Sbusiso Dlamini, and it's very similar to another question asked by Ndibuo Makondo. The question is that what plans are in place to upload proprietary data into the Copilot? So I'm assuming it's referring to pre-built, pre-trained models that are already available on the cloud service that you are providing. So essentially, do you have plans for people to use proprietary data for those models? And that ties to the question that Debo also asked, to say, are we able as users to upload complex engineering formulae, for example, onto these models and physics formulae and so forth that is not already existing within those models? If you could just give your thoughts on that.
Yeah, so what we're finding is that I've worked with a number of customers already, like with these private documents. Because the models that you see, like at the chat on ChatGPT, it's basically pre-trained, right? It's pre-trained with existing information on the internet, and there's lots of work that's been done on those data. Now, it's not going to know about your private documents that you have in your organization, right? Because it can't see it. But you would like to use your private documents to do some cool stuff with it, right? And so, like, one of the top use cases is just to search through the company policies and documents and previous tenders and things like that, so that you can get a heads up on writing the next one, okay, or answering the next one. And so that is what we find is that you don't actually need to retrain a lot of the model again, because you can actually just give it citations of what you're actually looking at in a body of knowledge that is private to you, and give it evidence of answering the question, and then it can synthesize a summary for you. And so finding information on your private documents doesn't require retraining in I would say 95% of all the scenarios. You do have the ability though to find what we call fine-tune the model, where you actually are now creating your own instance of ChatGPT, and it's private to you. What you will find is you could actually just write your own ChatGPT. There's people on the internet that's written their own open source code and things like that. But you won't get the same data, and you won't get maybe the same level of integration with those other models in the backend. But you can do it, right? So pruning, I think, and that would mean that you would run it on your own compute instance, and so it becomes more expensive to run it like that. Like if you were going to train it with only your model, your data, and create your own version of ChatGPT, it would be more expensive for you to run it, as opposed to give your data to ChatGPT in a specific instance of transaction, and then use that model for that instance. Like you saw in the Word example, where I'm taking maybe my meeting notes and my presentation and this Word document, and I'm combining that together to give me something new. In that case, you won't need to retrain the model with your data. You just use the model for what it's good at, but with your data. And what's cool about that is your data always remains private in your own private systems, or your own private space, a data lake or whatever, OneDrive and things like that. So you wouldn't need to give the company access to that, so that you can retrain the whole thing. But you do have the ability to train it. It's just more expensive.
All right. Now, gents, this is quite a broad and big topic, and I think you've given your best effort to address quite complex discussions within this short space of time. And unfortunately, we've now hit the end of the webinar. For the audience that had posted questions that we did not get to, those will be answered on by the presenters on the SAIEE website. They will be published under past events and webinars tab. So we'll still carry on this discussion, I guess, beyond the confines of this webinar. So I'd like at this point to thank you very much, gentlemen, for making the time and the effort to provide your expertise. And thank you to the audience as well for staying with us. And hopefully this is just a foundation for further discussions and innovations within the computing industry. I'd also like at this point just to invite anyone who would like to participate in the computing chapter and contribute and drive the technology forward. Mings will share the email address and all the information that's required to join. Thank you very much, and have a good evening. Thanks, gents.
Thanks.
Thank you for having us.
Thank you. Bye.
Thanks.
Bye.
Cheers.
Thank you to all the presenters. Thank you for joining us tonight. Ladies and gentlemen, you'll find if you want to become a part of the computing chapter chapter, you will find the email in the chat box, which is computingchapter@saiee.org.za. Please send a copy of your CV to that email address and you're welcome to join us. Thank you very much for joining us, and thank you, Sean, for hosting this wonderful, informative webinar. All have a good night. Until next time. Goodbye.
Bye.